Hi, I'm Toby Kaplan. For more than 30 years, I was a classroom teacher and a mathematics coach. Now I work with Symphony Math. I'm going to show you a routine that will take 15-20 minutes of your class time, and you can use it with your whole class, a small group, one-on-one. You can use it remotely, and it works with every Symphony Math task. The routine consists of having students make models, then think and talk about those models and make sense of all the numbers and the relationships they see between numbers so that they can have more ownership over their math mastery. Today's content is going to be Stage 13, multiplication. Multiplication builds on parts to whole because now we have repeated equal groupings, so those parts are groups of the same size, equal size. And this multiplicative relationship is the underpinning of our entire place value system. Our whole numbers and decimal numbers are all built upon this. You can find out more about repeated equal groupings if you look at the stage documentation in Stage 13 in Symphony Math Scope and Sequence. The materials today will be a grid, some interlocking cubes, and number cards. We're using the grid because, like all the other Symphony Math models that go up from the beginning of the program and keep being used as they get deeper into the content, this model makes use of the number bar, but we turn it into a grid or an array. Array is an arrangement of any object in rows and columns, and it's very frequently used in mathematics class to show multiplication. But it may just look like a trick or like magic to students. They're told, well, you just multiply the length times the width. And what we want them to do is make some sense out of why this model is useful and how it can work in multiplication. I'm going to show you a task that I would use with students, and here's how I might model it for them. We see here a problem that we need to make sense of. It says create a number sentence and a grid that has an area of 24 and is 6 tall. And what we see here is that, well, some number equals 6 times something. Okay, got to make sense of this and see how a grid is going to help me solve it. See, I've got a grid here. And let's work on this number sentence. Well, we know that it has an area of 24 squares. So I'm going to put my 20 and 4 more right here. Here's the 24. And we know that it's 6 tall, so it equals 6 times some number that we don't know yet. Let me also be marking on my grid at the same time. I'm told here it's 6 tall. 1, 2, 3, 4, 5, 6 tall. Okay, so let me just start that and label that this is 6 tall from here to here. Now I know something else. I know the area, or this whole inside, will take up 24 squares. So let me label this with my 24. What I have to determine then is how many of these 6 talls I need in order to cover 24 squares in all. Well, here is a bar that is 6 tall. 1, 2, 3, 4, 5, 6. That is 6 tall. And that's 6 right there. I've got to get to 24. Well, 6 more give me 6 and 6 is 12. 6 more again, I'll repeat it. 6, 12, 18. And 6 more again, 6, 12, 18. Now I've got 24. I see that each time I made a row of 4. And I have 6 of these rows. So 6 with 4 in each row gives me the 24 squares I needed. Let's see. We had 1. Here's another 6. Here's 6 more. So we could see that each row was 4 wide, 6 tall, and we know that 24 equals 6 groups of 4. I can now fill this in with a 4. 24 equals 6 times 4. What do you notice? What do you wonder? When we ask students to stop and what do they notice and what do they wonder, it's really asking them to take a few minutes to reflect on what they see. They may notice details that they wouldn't if they just immediately, quickly tried to come to an answer. We want them to make sense of this model. We want the grid to help them visualize the relationships that they see here. Here's something else you can do with this model. Just want to try something else. What if I rearrange this to say 6 times 4 equals 24. And I rearrange the order here. Would you do something differently if you didn't know this value and you had to solve for this value? Would you do something differently to solve it? Would this model work? What do you think? When we arrange the problem, we can check in to see if students are making sense of the equal sign. Doesn't matter if the equal sign is at the beginning of the number sentence or if it comes at the end of the number sentence. Does the area of 24 change? Do the two values change? Here are some questions you can ask students after they've had a few minutes to think about it and answer how they might solve this second task. I know that I had groups that were 6 tall, so why did I count by 6 to solve the problem? Did it make any difference when the area of 24 came at the beginning of the number sentence or when it came at the end of the number sentence? Do you think the grid model helps you see a multiplication problem? Do you think that the grid model helps you solve a multiplication problem? And as students talk and comment, you don't need to answer everything they say. You might want to encourage students to listen to and comment on each other's ideas. We're going to do a second task. It's a story problem. We find that story problems give students a context, and that helps them attach meaning to the values that they see in the problem. Here we have a story problem that we get to solve. Let's make sense of this. It says, Mr. B has to seat 20 students in the auditorium. He must safe distance them. He'll do this by putting 5 students in each row. Well, how many rows does Mr. B need in order to seat all 20 students? All right, let's make sense of this and let's use a grid to solve this problem. Well, Mr. B has 20 students in all. Okay, here are his 20 students in all. Now, we know he's going to seat them in rows. We don't know how many rows yet, and that each row will have 5 students in it. Let's see what we've got here. Here's a row of 5 students. Again, I want to mark this down. Here are my 5 students, but what I don't know is how many rows I need in all. 1, 2, 3, 4, 5. Let's label this to come all the way out to here. Let's color in the 5 that we already have. Here's 5. And we also know it's going to take up to 20 students that we want to seat in the auditorium. Well, here's a row of 5. In order to figure out how many rows Mr. B needs, I'll count up by 5. Here's 5. That's 1 row. Now we have 10 students seated because 5 and 5 is 10. Now we need 2 rows. The third row gives us 5, 10, 15 students. No. The fourth row means we now have 5, 10, 15, 20 students. So it took us 4 in each row. It took us 4 rows to seat the students. 1, 2, 3, 4 rows, 5 in a row. So we know Mr. B needs 4 rows in order to seat his 20 students 5 in a row, just like the problem. I'll move this over. Let me color in the rest of this grid. And make sure that we have, in my not very neat coloring, we have 5 in each row, and it took us 1, 2, 3, 4 rows to seat 20 students. What do you notice? What do you wonder about? After students have some time to think, make note of their language. Do they talk about squares? Do they mention area? Do they see rows or height? Do they see groups? Do they mention the word product? See if they made sense of the problem and how it matched up to the grid. Watch their gestures in addition to listening to their words and ideas. Let them talk to each other. Don't stop them, don't correct them, don't judge them. If you think they're ready, though, do let them know that they're now going to do some tasks on their own. Let them know they're going to do some independent tasks. You expect them to build models, make a number sentence, talk about their ideas, and be able to justify why their models work for solving the problem, and did it make sense. You can find additional tasks by going to Stage 13 in the guided practice in the Scope and Sequence page. And you can go to the demo mode and click on any task in Stage 13 and then project it onto a smartboard. After students have had 10 or 15 minutes to do some work on their own, and you're all the while listening to what they're doing and what they're saying and how their models work, you can ask some questions. How does a grid model help you show the groups? How do you know the groups have an equal number of squares? Where are the groups when you look at a grid? Where do you see repeated equal groups on a grid? When you've had time to have a conversation and students have had a chance to talk and make mistakes and do their thinking out loud and talking to each other, do some debriefing. That's where you get to wrap up the main ideas that you hope they learned today. What you could say to them is, today you see how a grid model connects to multiplication. Since multiplication is repeating equal groups, a grid helps us see this repetition when we look at rows of squares. We know that we can multiply rows of squares and columns to help us find the total area, and it also helps us find a faster way. Instead of adding repeated groups, we can multiply to find the area. When you make a connection between the grid model and multiplication, it helps your understanding of multiplication and makes it deeper for you. When your students go back onto the Symphony Math program, Stage 13, monitor how they're coming along. You can check their progress, and any students who show up in red signal to you that they'll benefit from more offline model making and talking, like we saw here today.